Okay, student, good morning. Today we are going to discuss chapter 5, Time Value of Money. Before our discussion on chapter 5, I'd like to give you the overall picture of the following chapters. So chapter 6 and chapter 5, chapter 6, chapter 7, we are going to discuss the time value of money, right? And return to risk relation. So for me, they are important finance skill. So after we know time value of money and return to risk relation, we are ready to do bond variation, stock variation, project variation. When I say bond, stock, and project, I know they will bring us money in the future, right? So bond investor, stock investor, or project manager, they have money in the future. Then variation is the value of the future money today, right? So they will bring us money in the future. We need to determine the value of future money today. After we know the value, management decision is simple. Value is higher than cost, we buy. Value is lower than cost, we sell. So variation is the key. To do the variation, we need to know time value of money and RR relation, return to risk relation. All right. So I would suggest students you consider the following 6 chapters together because they are related. Right. So chapter 5, time value of money. So we have 5 topics for this chapter. Today, I hope to cover the first 2 topics, right? Money at the time. Then we have future value, present value, interest rate, and the number of periods. All right. So money at a time. So as a finance person, I know time is important. So finance is about money. But when we consider money, we pay attention to time. Right? Time is very important. And in finance, we have 3 key concepts: risk, liquidity, and variation. Right. So here I give you my handwritten note. So finance is about money, but please know we are dealing with money in the future, not in the past. So accounting is to deal with the money in the past. So accounting is to record the money, but finance is to make money. So our focus is money in the future. Because we have money in the future, we have risk. So future money involve risk. And the risk return will go together because of market efficiency. High risk, high return, low risk, low return. Right? So we know why risk is important. Another point is liquidity. Liquidity is about timing of the money. Right? So risk of money, liquidity of money will determine the value of money. So value of money depends on risk and liquidity. All right. So we have not shown you the detailed calculation yet, but the concept is very simple. Risk and the liquidity determine the value of the money, right? So on this slide, we give you the basic definition of several terminology, right? In time value of money, we have present value. Present value is the earlier money on the timeline. Future money, later money on a timeline. Interest rate is an exchange rate between earlier money and later money. So for most of students, you think about interest rate. You might think about interest rate for saving or interest rate for loan. But here in finance, we have different definition of interest rate. Right? Interest rate is an exchange rate between earlier money and later money. Right? So again, my handwritten note here. So you might think about exchange rate. You know exchange rate like a US dollar to New Zealand dollar. But the exchange rate, US dollar to New Zealand dollar, is a currency domain. Here, we are discussing the time domain, mean present value, earlier money on the timeline, future money, later money on the timeline. Interest rate is the exchange rate between present value and future value. All right, so it's a general definition for interest rate. All right, it's an exchange rate between earlier money, or you can say today's money, right? Later money, like a future money. So exchange rate between today's money and the future money. And we have different definition of interest rate. So interest rate is a discount rate. So when I see the discount, I'm thinking the future money. Future money involves risk. So future money will have a discount. So interest rate is also a discount rate, right? Interest rate is a cost and it's also a return. So the idea is interest rate is a cost to borrower. It's also a return to saver or investor, right? So interest rate is a cost of capital. Is also a required return to investor. Finally, we'd like to discuss opportunity cost, right? So in finance, we consider opportunity cost. This is another difference between finance and accounting, right? So opportunity cost is important, right? So think about the example, like if you use your own money, right? For accounting person, they think your own money, so your cost is zero. But in finance, we use opportunity cost. That means when you use your own money in one project, you will lose the opportunity of other projects. Right? So in finance, we use opportunity cost. All right. I like to make a joke about this. Think about the opportunity cost like the marriage. Right? So accounting people, they think about a marriage cost like a party, honeymoon, travel, right? Accounting cost. For finance people, I will think about this way. When I get married with one girl, I will lose the opportunity of other girl. So you can see the opportunity cost is very high or huge. This is why we don't get married too early. Right? So you can see that this is another key difference between accounting and the finance. All right, opportunity cost. Okay, so next you can see in this timeline. On this timeline, you can see this variable. You have PV, earlier money, FV, later money, interest rate, the exchange rate between that, and finally we have the time. Right. So in the following discussion, we will show you the relation, a relation between the four variables: PV, FV, I, and T. Right. And we can use the relation to do a lot of finance decisions. Right. So next slide, we discuss the time value of money, consuming today or tomorrow. So for finance people, time is important. Here we give you a detailed example. So time value of money is based on the idea that people prefer to consume goods today rather than waiting to consume similar goods in the future. Right. So it's normal, right? We like to use the money today rather than using the money in the future. So money has a time value because a dollar in hand today is worth more than a dollar to be received in the future. So I gave you two reasons here. Today's money, the value of dollar invested at a positive interest rate grows over time. That means money can earn interest or return. So if you receive money today, today's money can earn return or earn interest. And future money, the money in the future is involved with uncertainty or risk. Right? So this is why we prefer using the money or having the money today rather than having the money in the future. So our conclusion is very clear. Value of today's money is higher than value of future money. This is about time value of money, right? So next slide, we give you an example, right? So here we have two offers. So think about this example. I give you two offers. Offer A, you will receive $300 today, right? This offer A. Offer B, we spread out the $300 for 3 years, right? So today 100, year one 100, year two another $100. So in math, they are the same. 300 is equal to $100 plus $100 plus $100. In math, they are same. But for finance person, they are different. The difference is time, right? The time. So which offer you prefer? I think most of students will choose offer A, right? Receiving $300 today rather than receive the $300 over 3 years. Right? So the idea is simple. So money received over time is not equal in value. All right. The reason is here. So let me give you 3 reasons. One, return. So if you receive the money today, you can use the money to earn return, or money can earn money. This first reason. Second reason is risk. Future money will involve risk. Right? Although I promise I will give you another $100 at year one or in the year 3, I might break my promise. Right? This is a risk. Right? So future money involves risk. For economics, they might consider inflation. Right? Inflation is another factor. Right? But in finance, our focus is return and risk. All right. So our conclusion is here. Money received over time is not equal in value. So our question is, how do we value future money? How do we value future money? Again, two factors to consider: risk and liquidity. Liquidity means timing. But I mean the risk of money and the timing of money, right? So next slide, we discuss the timeline and the problem solving. So when you do any finance question, I would suggest students prepare the timeline first. So timeline are an important tool for analyzing problems that involve cash flow over time. So the timeline is like a list, right? So you can see the timeline for a 5-year project, right? So you can, year 0 mean today, year 1, year 2, year 3 to year 5, right? So you address the timing on the timeline. Then you show the amount of money on the timeline. So negative mean outflow, right? So year 0, we have a cash outflow, $10,000, for example. Then year 1, 5,000 positive inflow. Right? So you can use the timeline to show cash flow as they occur over time. Right? And the term time 0 is used to refer to the beginning of the transaction in the time value of money problem. That means the day, the beginning day. All right. So In the following discussion, I will always prepare a timeline when I do any finance problem. Right? On the timeline, I can see the amount of money, the timing of money. All right. One more thing we like to address is here. So we know time value of money. Money received over time is not equal in value. So we cannot compare or add up the money if the money are at different, if money is at different time, because they are different in value. So you cannot compare or add up directly. To do the comparison or adding them up, we have to move the money to the same time first. All right. So you have a timeline. You know, you have a timeline, the amount of money, but you cannot compare the money directly, and you cannot add them up directly because time value of money. All right. They have different value, right? Because different time. Right? So in our following discussion, you always remember you need to move the money to the same time before you do the comparison or adding up. Right? So next slide, financial calculator and the Excel. To do the finance problem, you can use a financial calculator to do the calculation. So financial calculator will provide the calculation tool to solve most problems in the test. Right. So if you are interested in the finance certificate, like a CFA or FRM, I encourage you to use a financial calculator. Right. So financial calculator, as I show you, is here. Right. So you can see financial calculator. Financial calculator, you can see the PV, earlier money, FV, future money, right? I, interest rate. N is about time, number of periods, all right? You might ask me the PMT. PMT stands for payments, all right? So in the next chapter, we will discuss multiple cash flow. Here, we just have one single cash flow, right? So you might assume a PMT 0. So you can see 1, 2, 3, 4, and the 5 PMT. These 5 variables, they have a relation. Right? And the idea is simple. If we have 5 variables in a relation, by given any 4 of them, we may know the 5th. That's all. All right. However, you still need to understand the relation. What's the relation? To understand the relation, we draw the timeline. Right? We draw the timeline. About the calculation, you can use the financial calculator. Right? So financial calculator is just like an ordinary calculator, but now we have a program in the financial calculator. Right? The algorithm, that means the relation among financial variable. In addition to financial calculator, you can also use Excel. So in our discussion, I will focus on Excel because now we do the test online. However, if you are interested in CFA and FRN, I hope you can learn how to use the financial calculator. Right? Because when you do the CFA or FRN, you cannot use the computer. You cannot use laptop. The only thing you can use is a financial calculator. Right. You are welcome to discuss with me about the finance exam. I have the FRN certificate. I know the requirement. All right, but in our lecture, I will focus on Excel. Right. Finally, you need to know financial calculator and Excel will not solve the problem for you. Some students might think I have the financial calculator, I can do all the finance questions, but it's not. All right, it just helps. It's just a tool. Right? To get the correct answer to the real world problem, you must first analyze the problem correctly, then identify the cash flow. That means the amount of money time of money, placing them correctly on the timeline. Right. So like in our test 1 or test 2, I will ask our student to draw the timeline. All right, to hand write or hand draw the timeline. Okay? I can know you understand the time value of money. So the final number is not a problem, right? But I think the concept is important. All right. So you will know why timeline is important later. Okay, we finished the discussion on the first topic. Again, let me review some key concepts for you. So money at the time. So I know I need to draw the timeline. So on the timeline, I can see the amount of money and the timing of the money. And on the timeline, earlier money, present value. Later money, future value. Exchange rate. Interest rate is exchange rate between earlier money and later money. Right. So here our focus is time domain. All right. If you are discussing exchange rate between New Zealand dollar and US dollar, your focus is currency domain. Right. But here our focus is time domain. And I know money received over time is not equal in value. Right? So I cannot compare them directly, and I cannot add them up directly. Right? Here we give you several reasons. One, return. Today's money can earn return. Second, risk. Future money involve risk. Right? Inflation is another factor. But here in finance, our focus is return and risk. Right? So how we value the future money? The answer, we have to consider risk and the timing of the money. All right. So it's about the concept. Later on, we are going to show you the detail. Right? We have some calculation. So our first topic is future value calculation, FV. Then present value. Then interest rate. And finally, number of periods. So let's discuss our next topic, future value or FV. The future value of an investment is what the investment will be worth after earning interest for one or more time periods. The process of converting initial amount into future value is called compounding. This is our example. So single period investment. So future value at the end of year 1 is principal plus interest earned. So here our principal is $100 and the interest rate is 0.1 or 10%. So your interest earned will be $100 times 0.1 is $10, right? So we can rewrite our calculation, and finally the answer is 110. Right? So your $100 will become 110 at year 1. We use a general equation. So future value FV at year 1 is P0. P0 means principal. Principal at year 0 times 1 plus I. I is our interest rate, right? I think this example is not difficult to understand, like a saving plan, right? Now we do 2-period investment, all right? So now we concern the future value at year 2. So future value at year 2 will be future value at year 1 times 1 plus I again. Therefore, it's P0, principal at year 0 times 1 plus I with power of 2. Right? In our example, principal $100, interest rate 0.1. And our time, 2 period, power of 2. Finally, our result is $121. Right. Again, I think this example should be okay for our student. So based on the 2 examples, now we are going to discuss a general equation. A general equation to find the future value after any number of period is here. So FV is PV times 1 plus I with power of N. So again, PV, earlier money or today's money. FV, later money or future money. I is our interest rate. N is the number of the period. Please note, number of period could be, the period could be a year, a quarter, or month, or day, or some other units of time. All right. We will discuss the compounding frequency issue later. Right. So N is the number of period. And 1 plus I with power of N is future value factor. Right. So today's money, after N period, your money will become PV times 1 plus I with power of N. Right. Here we discuss the compounding effect. So we have the simple interest versus compound interest. So this is our example. Again, initial principal $100, interest rate 10%. So how much will you have 2 years from now? If we consider the simple interest, $100 your principal, $10 interest for year 1, another interest $10 for year 2. So together 120. This is simple interest. But based on our calculation, future value at year 2 will be $100 times 1.1 with power of 2. Or $100 times 1.1 times 1.1. The result is 121. So you can see the difference. 120 versus 121. We have extra $1. The extra $1 comes from the interest of 0.1. That means year 1 you have $10 for your interest. Your interest can earn interest. So we have interest on interest. $10 times 0.1, $1. So this is extra money, $1, come from interest on interest. All right, or you can say money can earn money. Right? Please note, in practice, we use compound interest. All right, so money can earn money. All right, so this is the compounding effect. All right, or interest can earn interest. Right. On the next slide, we discuss the compounding frequency. I mean, compounding more frequently than once a year. So in our previous discussion, our compounding frequency is annual. So we have payment every year. But here, we might consider another compounding frequency. For example, here, semi-annually. When I see the semi-annually, that means twice a year. All right. So you invest $100 in a bank account that pay 5% interest rate semi-annually for 2 years. Right. In our calculation, you have to convert your data according to payment frequency. In particular, semi-annually, twice a year. Right. So 5% is our 1 year rate. Semi-annual rate will be 2.5%, or 5% divided by 2. Right, this is our semi-annual rate. And 2 years, right? Our semi-annual period will be 4. Right, 2 years times 2, 4 semi-annual period. All right. So our future value at year 2 will be $100 times 1 plus 0.025. That means semi-annual rate with power of 4 rather than 2. Because our period, semi-annual period. And you can see the final result is here. So given this example, we like to give you the general equation. So future value at year N will be PV times 1 plus I over M with power of M times N. M is the number of compounding period per year, right? N is the number of year, right? So you can see we adjust our data according to compounding frequency. So you can see our I is 1 year rate. Our period rate is I over M. Number of period will be M times N, right? We have an example for you to practice the compounding frequency. So here we have the initial investment, 10,000, and the bank A, B, C, D. And the compounding frequency annually, quarterly, monthly, and daily. This column is a rate. This is an annual rate or 1 year rate. Please know you have to convert the rate or adjust the rate according to payment frequency. And finally, we calculate the value after 5 years. So future value at year 5. This is the answer. But calculation is not our focus right now. I want to address the key concept here. So the point is you have to adjust the data according to compounding frequency, right? In our example, this is 5-year investment. So quarterly, when I see the quarterly, I'm thinking 4, right? 4 quarters a year. So our quarterly rate will be I divided by 4. And the number of period will be 5 years times 4, all right? Monthly, when I see the monthly, I'm thinking 12 months a year. So number of period will be 5 years times 12. And our monthly rate is I over 12. Right? Daily, if we have compounding frequency daily, that means we have interest on interest every day, right? Every day. And now you can see how we adjust our data. Number of period, 5 years times 365, right? 365 a day a year. And the daily rate, I over 365. All right. So here we just give you the example, and you can see how we adjust the data according to the compounding frequency. All right. Okay. Next slide, we discuss the continuous compounding. If we can continue to divide the compounding interval into smaller and smaller time period, such as minutes and the second, until at extreme, we would compound continuously. In this case, M would approach infinity, and our final result is here. Future value is present value time. The E is a spatial function, is a exponential function, right? In your financial calculator, you can see this function. So if you see your financial calculator, there is a E function is here, all right? E, right? And Ln is a natural log, but I don't want to spend time to discuss the explanation function. I learned explanation function when I was a high school student. I don't need to remember that. But I like to discuss the concept, all right? So I just copy our previous formula, all right? So FV is PV time this term. M is number of compounding period per year. So continuous compounding, that means we have compounding frequency, not just every day, right? Every hour, every minute, and even every second. That means our M approach to infinity, right? So this is a special case. Then our final result is here. E is an exponential function. Right? So our future value will be present value time exponential function with power of I times n. Right. If you study the master program or PhD program, you can see in finance we will use continuous compounding. All right. But for undergraduate student, I think you just know that, right? We don't need to use the continuous compounding, right? But you may know the concept. Right? But you might ask me why we use exponential function. Exponential function has some good character, have a good character for calculation. But I think it's too much for our undergraduate student, right? So we don't need to understand the detail. Okay. So next slide, using your financial calculator. So yeah, we know the formula and the calculation. We can use the financial calculator to help the calculation. Right? So you can see this financial calculator I recommend. Again, we have many financial calculator in the market. I recommend this one because CFA exam. All right, they recommend this financial calculator. So you can see the future value, present value, I over Y. I over Y is the interest rate, period interest rate. So I over Y, please note, when you enter the interest, you enter a percent, not a decimal. For example, 4%, you enter 4 rather than 0.04. All right, and the n number of period. Right. When you do any calculation, you need to clear the data you enter before. Right. One more point: adjust the data, adjust the interest rate and the number of periods according to compounding frequency. Like I say, I will not pay too much time, spend too much time on financial calculator. In our discussion, I will focus on Excel. All right. So another tool is Excel. So you can use the following formula for time value of money calculation. So we have FV, PV, rate, and the NPER formula. Right. So FV depends on rate, number of period, PNT, and PV, right? So you can see we have 5 variables here. 1, 2, 3, 4, 5. 5 variables. They have a relation. About a relation, think about the timeline, right? They have a relation. And by given any 4 of them, we may know the fifth, all right? So you can use a FV formula, PV formula, rate formula, and the number of period formula. Right? So the Excel formula is useful when you cannot remember the exact formula, right? But you have to remember the timeline. Right? So please do the adjustment. So adjusting the data according to compounding frequency. And again, the Excel file are available on Moodle. Right? And I will suggest students you download the Excel file and practice yourself. Right? So I will change the input number and you can see how the output number will change, right? So we give you example to use the Excel file, all right? So you have $10,000 to invest and you need the money in 5 years and you expect to earn 8% per year. How much will you have in 5 years? So you can see PV is earlier money. You have $10,000 today. And the number of period 5 years, red is 8%. So again, when I do any question, finance question, I draw the timeline. Timeline today, $10,000 earlier money, right? PV. We want to know future value at year 5. Interest rate is 8%. Number of period 5 years. And I know there's a relation between the 4 variables. Even any 3 of them, we may calculate the force. All right. And you can see in Excel, we just have the input variable PV, NPER, and the RAT. We use a future value formula. All right. Please note, when you use the Excel, you have to follow the order. All right. So first variable, G5. This is our rate. All right. This is our rate. And the second is G4. PMT 0, finally G3. G3 is our present value. You have to follow the order. All right. And please note, we have a negative sign before the future value. Right. This is a sign convention. That means PV and FV, they have an opposite sign. The idea is simple. PV and FV, earlier money and the future money. One is inflow, the other is outflow. Outflow negative. But in finance, we don't like negative value. So I add a negative sign in front of future value to make the result positive. All right. So we have one more question, then we can end today's lecture. Compounding effect. So you can see the Peter bought Manhattan Island, $24 in 1626 was a good deal, right? So normal people might think $24 to buy an island is a good deal, right? The price is very low. However, to answer the question, you need to ask how much $24 is worth in today or in the year of 2023 or 2025. If we consider interest rate is 8%, all right. So you can see the time from 2023 minus 1626, the 397 year, and your $24 after 397 year, the answer is $446 trillion, right? And the value of the island is well below this number, right? So the point is here. When you do you cannot compare the money directly. $24 is a payment in 1626, right? About 400 years ago. You cannot compare $24 400 years ago with today's price. This comparison makes no sense because the time value of money. So you move $24 to today, and the result is over 400 trillion. Then you make a comparison. You can see the price today is lower than this value, right? So this is the point. Okay, I would like to end the lecture here. And again, before we go, let me review some key concepts for you, right? So in the future value, I know future value and the compounding. I know the difference between simple interest versus compound interest. I know how to calculate the future value using the Excel or financial calculator, right? And I know I need to adjust the data according to compounding frequency, right? So these are original formula. If we consider M m the number of compounding per year, compounding period per year, you see the adjustment from I to I over n, from n year to m times n periods. All right. Finally, we discussed the continuous compounding. We have the explanation function. Okay, we still have 3 minutes. One more thing, attend the recording. Give me a minute. Right, student, you can use the QR code to record your attendance today. Thank you for attending today's lecture. Enjoy the sunny day and see you on Friday.